Now that we know what an exponent is, I want to talk about our properties of exponents. Let's start with the fundamental definition of what an exponent is. For instance, when we have x to the fifth power times x to the third power, when we multiply these two terms, let's look at what happens. Remember that fundamentally, x to the fifth means the base, x, times itself 5 times. Times x cubed means x times itself, the base, 3 times. But when we have x times 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 x, remember what that actually means is by definition, since I have 8 of the same base, x to the 8th. This is the shortcut of when we would add exponents. The shortcut to get that x to the 8th. Now, expanding it out will work to help us show what's really going on fundamentally, and even when we get into our negative exponents, our zero exponents, all these same definitions are what we're going to use to show why they work. But what we're trying to learn now are the shortcuts. This one is what's called product of powers, and don't worry about its name. We won't ever call these by name. What we're more interested in is when do we use the shortcuts and what shortcut do we use. Sometimes, in this case, we're going to be adding exponents. As long as I have that same base, I just add the two exponents. Later, we're going to be multiplying exponents. Later, we're going to be subtracting exponents. And it's all a fundamental of recognizing what operation are we doing at the time. Let's look at an example. If I have 5 to the 8th times 5 to the 10th, the last thing I want to do is try expanding these out and counting how many I have. And the absolute last thing I want to do is try actually multiplying these. But remember, 5 to the 8th means I have 8 of those 5 sitting there. 5 to the 10th means I have 10 of those 5 sitting there. How many 5s do I have? I have a product of 18 of those total bases. Let's look at another example. X to the 17th times x to the third power. Well, those of us coming straight from Math 099, or those of us with a vague sense of remembering this from high school or previous courses, see those parentheses, but that makes no difference in this case. We're going to see that extreme here in the next problem. Remember, x to the 7th means I have 17 of those x's. X to the 3rd means I have 3 more x's. How many x's do I have? It would be a total of 20 of those bases. Now, I also want to look at what happens if we have coefficients. What happens if I have 5x squared times 3x cubed? Well, remember, when we have a coefficient, go back to the last few videos, a coefficient means multiplication. What I want to do is multiply those two coefficients. And in this case, remember, x squared means I have 2 x's, x cubed means I have 3 more, 5 total x's. What we're going to see, and we're going to hear this a lot, especially when we get into our distributing polynomials and some of those, we're always going to end up multiplying the coefficients. Remember, that's what a coefficient is multiplication. We're going to end up adding the exponents, product of powers.